let's use those tools we've just learnt to calculate probably the most common statistical idea, and one I hope you're already familiar with. So that's the mean, or the sample, or the average. Now we write mean as x with a bar on the top of it, like that. So that means the sample mean. We'll talk about the mean of a whole population later, but this is the sample mean, and that is equal to the sum of x over n. So that means you add up all your different measurements and then divide it by the number of measurements. So the sum of all the measurements divided by the number of measurements. Okay, so let's do a couple of examples. So let's say we've got a data set. So let's say we've got 2, 3, 4, 5, 6, 7, 8. So there, n is equal to 7. There are 7 different measurements here in our sample, and so the mean, x to the bar on top, is equal to the sum of x over n. So that's 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, all over 7. N is 7, so that's equal to 35 over 7, which is 5. Fairly straightforward, I think. So I've got a couple of points I want to make. So this is a useful way of seeing the central tendency of our data set, but it might not tell us everything. So for example, so here we've got a sample with a mean of 5. How about if we've got a data set of -5, 0, +5, +10, +15. So in this case, our mean is equal to the sum of x over n, so that's -5 plus 0 plus 5 plus 10 plus 15, all over 1, 2, 3, 4, 5. So here n is equal to 5. So that is 25 over 5, which is equal to 5. So these are quite different data sets, but they each have the same average, which may or may not that's just a point to make. And another point I want to make is that the mean is very sensitive. Mean is quite sensitive to extreme values. So let's imagine we add one massive outlying value to this first data set. So how about if we've got a data set of 2, 3, 4, 5, 6, 7, 8, and 1,000. So we've got 7 values that are quite close together, and then one that's much larger. So that mean x, so our n is equal to 8 now. We've got 8 different values. Is equal to the sum of x over n, which is equal to 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 1,000, all over 8, which is 129.4. Oh. No, I'm sorry. Just copied that down wrong off my notes. So obviously that's equal to 1,035 over 8, which is 129.4. So you can see, even though almost all the values are the same between these two data sets, they have a really, really, really different mean, or average.